Hello everyone, and welcome back to another episode of the Internet Computer Developer Journey. In today's episode, 4.4 NNS Governance and Staking, we're going to be getting an introduction to the NNS, SNSs, and we're going to take a look at how we can stake some ICP in a neuron and use that to give us voting rewards and voting privilege on the NNS. I will note that all of the concepts we go over today are going to be high-level overviews of each concept, and if you want to learn more about the NNS, staking, neurons, proposals, or anything else, we have a brand new series on the YouTube channel called NNS Explained that goes into each of these concepts in depth and walks you through a lot of the common workflows that you'd be interested in. So this video is a great introduction, but I definitely recommend that you go and check out the NNS Explained series on the DFINITY YouTube channel for a deeper dive into everything we're going to talk about today. So to get started, the NNS is a term that you may have seen before when thinking about ICP or trying to learn more about ICP. And NNS refers to the network nervous system, which is the body that governs the ICP network. So traditionally, when a blockchain needs to be upgraded or there needs to be a fundamental change made to either the architecture or the technology behind the network, the blockchain can only be upgraded via a method known as a hard fork. So that hard fork involves substantial work, manual coordination, and it leads to things such as the Ethereum fork a couple years ago led to the creation of two separate networks, Ethereum Classic and then Ethereum as it is now. And in that instance, the Ethereum network wanted to upgrade its consensus protocol and change from a proof of work consensus mechanism to a proof of stake consensus mechanism. And so it changed a lot of the underlying technology used on the platform. And the only way that they were able to do that was through this hard fork method. ICP is different because ICP can be upgraded through NNS proposals, which means that users that have staked ICP on the NNS in what we call a neuron have the ability to vote on different upgrades to the network. And then whenever that proposal is accepted or rejected, if it's accepted, those changes are automatically applied to the network. And in this way, ICP is able to upgrade pretty frequently, and we see it upgraded about once a week. So the NNS is a form of decentralized autonomous organization, or a DAO, which is a governing body where no one is the sole controller of the network. All of the network's decisions and changes are done on a voting basis. So every single thing that needs to either be updated or added, or in some cases rolled back on the network, everything has to be done through a proposal that is accepted by the majority of the voting parties on the network. This is to allow ICP to be governed in a secure, open, and decentralized way. Everything about the NNS is hosted fully on-chain and is responsible for every aspect of ICP as a protocol. A couple examples of upgrades that are made to ICP through the NNS are upgrading the software that's used on the network's node machines, adding new subnets, splitting or dividing subnets, or configuring economic parameters that control how much users pay for resources through cycles. So I mentioned staking in neurons. So what does that mean? So a neuron is an entity that can hold ICP tokens in return for benefits such as voting power or voting rewards. So an ICP token that is staked in a neuron cannot immediately be withdrawn. Neurons require that a notice be given before the ICP can be withdrawn. That notice is known as the neuron's dissolve delay, and that determines how long the neuron will take to dissolve if that neuron is placed into the dissolve mode. Once that delay is up, so it has a timer that will count down. Once that countdown is up and the neuron is considered dissolved, then the neuron owner can unlock that balance of ICP tokens, and they can either withdraw it into a wallet and spend it or convert it into a different token, or they can use it to stake in another neuron or do some other network use case with it, like convert it into cycles and use it for developing dApps that can be used however they like once it is unlocked from the neuron fully dissolving. The reason for this is it provides neuron owners with an incentive to vote with a long-term view that's focused on maximizing their ICP's value at a later date. So if you lock ICP tokens into a neuron for a longer period of time, you're going to get more voting rewards and more return on that initial investment. The neuron's voting power is proportional to how much ICP is staked in the neuron, the length of that dissolve delay, and then the amount of time since the neuron was created. So once you have ICP locked in a neuron, the minimum that you can lock it in is for 6 months. The maximum is currently 8 years. And so once you have it locked in for at least 6 months, then you can start to participate in the governance of the network and begin voting on proposals. You can decide to vote manually or automatically. So if you want to vote manually, you can log on to the NNS App, which we'll take a look at in just a moment. And you can click on one of the proposals that's currently accepting voting. You can review the proposal's details, take a look at all of the different pieces of the network that are affected by whatever the proposed change is. And then you can choose if you want to vote for this proposal to be accepted by the network or if you want it to be rejected. If you don't have the time or the resources to vote on every single proposal, your neuron can be set up to vote automatically by following the votes of another group. And we'll talk about that in detail in a bit more, but there's a great NNS Explained video on following and staking. It is worth noting that the voting rewards that you receive are reflective of how active you are as a voter on the network. So you're going to receive more rewards if you vote on every single proposal, and that's why it's recommended that you either have the potential resources to vote manually on each one or set up neuron following so that even if you don't have the ability to vote on every single proposal yourself, you can go ahead and still benefit from the maximum voting reward since your neuron will be voting automatically for you. So like I mentioned, each change to the network is done through a proposal, and this is what your neuron is going to be voting to either accept or reject on. Each proposal has a set of fields, such as a summary, a URL that contains additional content that is required to evaluate the proposal, the ID of the neuron that submitted the proposal, the type of proposal, any parameters that are going to be passed to the system function if the proposal is approved and executed, and then the unique identifier that the NNS assigns to each proposal. Any neuron can submit a proposal to the NNS. Now, as a developer, you may be wondering, why does the NNS matter to me? I'm just wanting to build applications. I'm here on my developer journey, wanting to code and build really cool things. Why do I care about governance? Well, there are several reasons why all users and developers on ICP should be familiar with the NNS and take part in the governance of the network. And specifically for developers, one of these key reasons is a lot of proposals are feature related, and so if there are proposed features or architecture changes to the network, it may affect your project's architecture, your developer workflow, or even the functionality of your application. And so it's important to stay up to date with what changes the network is going through so that if there are breaking changes that you need to allocate for on the developer side of your dApp, you can be sure to take that into account. It's also exciting to see new features that may unlock new capabilities for your application. Another reason is because neuron owners have the ability to submit proposals themselves. So if there is a change that's necessary for your project, you're able to submit the proposal that introduces that change. Since you can receive ICP rewards for participating in voting, you can convert those into cycles, which are necessary for your canisters to run on chain. And then lastly, by having a comprehensive understanding of the NNS, it can allow you to envision possibly implementing an SNS for your project, and it'll just give you better insight into potential ways that your application can be governed if you'd like to go that route with it. So I mentioned that term SNS, which stands for a service nervous system, and that is the ICP's version of a DAO. And it's a pretty advanced form of a DAO because it closely resembles the architecture of the NNS, but instead of being used to control the entire ICP network, an SNS is designed to control a specific application that's running on ICP. So any application on the mainnet can be handed over to an SNS, which results in that application being owned and controlled by its community. When an SNS takes control of a dApp, the dApp is then managed similar to how ICP is managed, meaning that it requires each change made to the dApp to be done through a proposal. The SNS will also have its own unique token that's used by the community for participating in the SNS's governance. Those tokens can then be staked in a neuron specific to that SNS, and then they can use that neuron to vote on proposals for the SNS. So a quick overview of how an SNS works. The core architecture behind an SNS resembles that of the NNS, but the NNS will contain additional canisters that provide important functionalities to ICP, such as the CMC or the cycles minting canister, which the SNSs do not have a need for since their applications are not having you mint cycles in order to deploy anything on that application. In contrast, though, the SNSs contain a few canisters that do not exist on the NNS. The most notable of that is the swap canister that's used to facilitate a decentralization swap during the launch of an SNS. And we'll talk a little bit more about decentralization swaps in just a moment. It's important to note that all SNS canister code is approved by the NNS community, and thus all SNSs follow the same upgrade path. Launching a new SNS is also approved by the community, including the initial settings of the SNS and the conditions of that decentralization swap. So typically an SNS has a governance canister, a ledger and archive canister, an index canister, a root canister, and then a decentralization swap canister. So more about those decentralization swaps. So in order for an SNS to be launched, it must have a successful decentralization swap. This is the action of initially funding the SNS by swapping ICP tokens for the SNS's native token. And this is done through that decentralization swap canister that is owned and operated by ICP. It is controlled by the NNS root canister. When the swap first starts, there is a predefined amount of tokens that are distributed publicly. So during that swap, participants that want to be involved in that proposed SNS can swap ICP tokens to that SNS swap canister and contribute to the initial funding of the SNS. When the swap ends, all of the ICP tokens are swapped for that SNS's tokens, and anyone who participated receives the SNS tokens in the form of SNS neurons. The amount that they receive is prorated by the amount of ICP tokens that they contributed to the overall amount of ICP collected in the swap. So for example, if the swap canister initially held 1,000 SNS tokens and there was 500 ICP tokens collected during the swap, then the exchange rate would be 2-to-1, meaning each participant would receive 2 tokens for each ICP token that they contributed. All of these tokens are then placed in a treasury that is controlled by the SNS, and once the swap is over, the tokens are owned by the community and the SNS is governed by that community, and whatever they want to spend the treasury tokens on, they decide through proposals. So there are lots of resources on this page about the SNS Tokenomics, SNS rewards, and then lots of further reading about the different stages of an SNS launch, how to set up your dApp to be eligible and able to be an SNS, how to participate in an SNS. So there's lots of resources here. But moving on, we are going to jump into using the NNS dApp. And like I mentioned, there is a really great series on this channel called NNS Explained that has another video on using the dApp for different specific functions. We're just going to go through a very high-level overview of using it here today, but I encourage you to check out that video for more details. So when you first navigate to the NNS dApp, it's this nns.ic0.app URL. And when you first log in, you're going to see this interface that shows you the balance for different tokens. And you'll notice that there are ICP tokens, some of the chain key tokens, and then everything below that is going to be the DAO or the SNS specific tokens. So you can see that there are SNSs for OpenChat, Origin, Sonic, Water Neuron. And so to see our token balances for each of these, we're going to need to sign in with Internet Identity. So I'm going to go ahead and click that. I'm just going to use this first one at the top of my list here. But of course, use whichever internet identity that you'd like. And if you need one, go ahead and create one. And if you need more information about internet identity, check out the previous video 3.1 Identities and Authentication. So once we're logged in, we can see my token balance for each of these tokens. And we can see that I have 9 ICP tokens in this internet identity. But you may need to transfer tokens into your internet identity main account. And so if you wanted to do this, you would click on your internet computer balance at the top here, and then click on this main account here, and it will show you a QR code that you can scan if you want to transfer tokens that way, or your ICP address to transfer tokens to. And so remember, if you need to obtain ICP tokens, you can purchase them through an exchange, or they can be received through other activities, such as receiving grants from the DFINITY Foundation, or participation in community events like hackathons or things of that nature. So once you have this QR code and this address, you can either send tokens directly from an exchange, or if you have tokens in your local DFX developer identity, if you bought a bunch of tokens and only converted some of them into cycles, if you have some of them still in that developer identity, you can use DFX to transfer them. So let's take a look at an example of that quickly. So I'm just going to open up my CLI here and just resize it a bit. And then I want to DFX identity I want to use my dev journey identity. And then I'm going to do DFX identity get principal to get the principal of this identity. And now let's see what the balance of this identity is. So DFX ledger network IC balance. And we can see I have 9.9 ICP tokens here. And so now if I want to transfer just one to my internet identity balance here on the NNS, so now I'll have 10 tokens, I can do DFX ledger network IC transfer. And then the destination is going to be this ICP address here. And then ICP, and then the amount, I'm just going to transfer 1. And then memo is a 64-bit number that is just used for creating a unique hash for the transaction. So I'm just going to give it memo 1. And then we're going to hit enter. And so now we can see I have 10 ICP in this balance here. So now if we want to stake that in a neuron, we can go over to the menu here and we can click on neuron staking. And then if I want to stake ICP, we can click this button at the bottom, stake ICP. And we can see that the screenshots have slightly changed since I initially put these here. So I will update these after the video. And so to stake ICP, we'll hit stake ICP at the bottom, and then we'll enter the amount. And for this, I'm just going to put 1 ICP and then hit create, and it will take a moment. And then it should come up with this dissolve delay screen. And so then here we can set the dissolve delay. So we can either choose the minimum, which is at least 6 months, or we can choose the maximum, which is 8 years. And so I'm just going to go ahead and for right now, just choose the minimum. And so we'll set delay, and then we will just confirm and set delay, since that is what we want to set for this tutorial as an example. And then here we can choose which neurons that we want to follow to automate our voting. And these are sorted by different proposal types. So these are all of the different proposals that can be submitted: governance, network economics, node admin, participation management. And so we can choose to do these each individually, or we can choose all except governance and SNS and neurons fund. For this, I'm just going to click on governance and just set up a following rule for only governance proposals. I'm going to click add followee. And then here we can see all of the options for groups that we can follow. So these are all either known organizations in the NNS ecosystem, or they are known neurons. And so here I'm going to select, I want to follow the DFINITY Foundation for their voting on the governance. And then here we can see that now I have DFINITY as a following rule for governance. And then for node admin, let's say I want to add a different group. Let's say I want to follow ICP Hub Poland for the node admin decisions. And so now those are set, and I can go ahead and close that. And then if I want to confirm those settings, I can click on the neuron ID, and I can see its current voting power, how that voting power is calculated, the amount of ICP I have staked. I can increase that stake. I can start to dissolve it, meaning it will begin to count down unlocking this one ICP token for me to use somewhere else. Or I can also increase the delay if I want to have it be longer than the current 6 months. And then down here, you can see those two following rules that I set up. And so now if we want to use this neuron to interact with an NNS proposal, we may not be able to, since neurons are only eligible for voting on proposals that have been submitted after they have been created. So they can't vote on a proposal that existed before they existed. But we can see I have this other neuron that has existed for a couple of months now. So I can go ahead and vote with that neuron instead. And so we can see that I have 5 actionable proposals here that I can vote on. And we can see that we've got 3 proposals for NNS canister upgrades. Let's see, one of them is upgrading the WASM of the NNS canister with this canister ID here. This NNS upgrade is adding the new CK-ERC token CK Uni. So let's go ahead and vote on that one. And I'm going to vote to adopt this. I am supportive of adding another CK-ERC20 token. So I'm going to adopt this proposal, and it's going to ask that am I sure if I want to cast these votes for the proposal? And I'm going to say, yes, I'm sure. And then we're going to see that the adopting the proposal vote that I just submitted is going to be submitted to the neuron. And then we can see on the bottom here, one of my neurons has voted, and my ineligible neuron was not able to participate because it was created after the proposal was. And we can scroll down, we can see some additional details about the proposal. We can see a summary, which was that description that's adding that new CK-ERC20 token. Then we can also see technical details like the Git hash, the proposed WASM hash, the motivation behind adding this token. And then we can also take a look at the details about the token, such as its smart contract address on the Ethereum mainnet, the Uniswap website, and then just additional technical details about the proposal. So that'll wrap things up for today's episode of the Internet Computer Developer Journey. Like I mentioned, if there's anything in this tutorial that you want further details on or a deeper dive into, definitely check out the NNS Explained series. If you have any questions, be sure to leave them in the comments or leave us a question on the Developer Journey forum thread on the ICP Developer Forum, or chat with other people on their developer journey in the ICP Discord server. Be sure to like and subscribe to the DFINITY channel to be updated when new episodes of the Developer Journey are released. All of the links and resources in the description box below are also great resources to learn more. That'll wrap things up for today. Take care.